Hello viewers, you are welcome to my channel. In this video, we are going to study angle properties in a circle. We'll study 5 properties in this video and continue with another 5 properties in the next video. And finally, we'll combine all the properties to solve past questions and likely examination questions. To understand the properties very well, you have to participate in the activity under each property. You need a compass, a pencil, a ruler, and a protractor. Without wasting much time, let's go straight to property 1. Activity for property 1. Let's draw a circle of any radius and then join the center of the circle to any point on the circumference of the circle with a straight line, and that is the radius of the circle. Let's draw a tangent to touch the radius and label the tangent T. We are going to measure the angle between the radius of the circle and the tangent to the circle. So with our protractor, we measure this angle. If you got 90 degrees, you are right. Automatically, this side will also give us 90 degrees when measured. And this brings us to the first property, which says that the angle between the tangent to a circle and the radius of the circle is 90 degrees. Now let's apply property 1 to solve this example. The question says PT is a tangent at T to a circle, center O. TU is a chord of the circle and angle PTU is 62 degrees. Find the size of angle TOU. So this is the angle they want us to find. Now clearly, PT is a tangent and TO is a radius. And the angle between the tangent and the radius of a circle is 90 degrees. So angle PTO is 90 degrees. Now to find this small angle UTO, this small angle, the whole of this angle is 90 and part of it is 62 degrees. So when we subtract 62 degrees from 90, we get this small angle. So angle UTO is going to be 90 degrees minus 62 degrees, which gives 28 degrees. So let's put our 28 degrees here. And also, TO is the radius and UO is another radius. And the radii of a circle are equal. So TO is equal to UO. And that makes triangle UTO an isosceles triangle, since two sides are equal. So the two base angles must be equal. So this angle is also 28 degrees. So that is angle TUO is the same as UTO and they are all 28 degrees. And the sum of the interior angles of a triangle is equal to 180 degrees. So angle TOU, which is this angle, plus 28 plus another 28 degrees should give us 180 degrees. So we add this 28 plus 28 and we get 56. And then 56 crosses the equal line to subtract from 180 degrees, and angle TOU gives 124 degrees. Activity for property 2. Draw a circle of any radius. Label the center O. Draw a straight line passing through the center and ending on each side of the circumference. That line is the diameter of the circle. Put a point on any part of the circumference of the circle and join the ends of diameter to that point. With our protractor, we are going to measure the angle subtended by the ends of diameter of a circle on the circumference. So this angle. If you got 90 degrees, you are right. And that brings us to property 2, which says that the diameter of a circle subtends an angle of 90 degrees at the circumference of the circle. Now let's apply property 2 to solve this example. The question says O is the center of the circle above. AB is the diameter. Angle ABC is 51 degrees. Find the size of angle BAC. So they want us to find this angle. AB is the diameter, and any angle the ends of diameter will subtend on the circumference is 90 degrees. So angle ACB is 90 degrees. And the sum of the interior angles of a triangle is equal to 180 degrees. So angle BAC plus 51 degrees plus 90 degrees should give us 180 degrees. So angle BAC plus these two angles, 51 and 90, will add up to 141 degrees. And it should be equal to 180 degrees. 141 crosses the equal to line to subtract. And finally, angle BAC is equal to 39 degrees. Activity for property 3. As usual, draw a circle of any radius and draw a chord. That's a line that joins 2 points on the circumference of a circle. The chord divides the circle into 2 segments, this segment and that segment. Now put 2 or more points on the circumference of the circle in one segment. And then we join the ends of the chord to each of the points on the circumference. That will give us 3 angles. Let's label them A, B, and C. And now with our protractor, we are going to measure angle A, B, and C and compare them. If you observe that the 3 angles are equal, then you are right. And that brings us to property 3, which says that a chord or arc subtends equal angles at the circumference in the same segment of a circle. So the angles must be in the same segment. That all should be in this segment or all should be in this segment. Let's apply property 3 to solve this example. The question says in the diagram above, AB is a chord. Angle ACB is 46 degrees and angle BAD is 80 degrees. Find the size of angle DBA. So they want this angle. Clearly, the chord AB subtends an angle of 46 on the circumference, and the same chord is subtending another angle on the circumference in the same segment. So angle ADB should also be 46 degrees. And the sum of the interior angles of triangle ADB should give us 180 degrees. So angle DBA plus 80 degrees plus 46 degrees should give us 180 degrees. So we add 80 to 46 and it gives 126 degrees. And 126 crosses the equal to sign to subtract from 180 degrees. And finally, angle DBA gives 54 degrees. Activity for property 4. Draw a circle of any radius and label the center O. Now draw a chord of the circle of any length and join the ends of the chord to the center of the circle. And put a point on any part of the circumference of the circle. And again, join the ends of the chord to that point. Let's label this angle A and this angle B. Now with our protractor, let's measure angle A and angle B and then compare them. If after comparing, you notice that twice angle A will give you angle B, then you are right. And that brings us to our fourth property, which says that the angle a chord or an arc subtends at the center of a circle is twice the angle is subtends at the circumference. Now let's apply property 4 to solve this illustrative example. The question says O is the center of the circle above. Angle CAB, which is this angle, is equal to 34 degrees. Find the size of angle COB. So they want us to find this angle. And the chord CB subtends an angle of 34 degrees at the circumference of a circle. And the same chord subtends an angle COB at the center. So 2 times the angle on the circumference should give us the angle at the center. So angle COB will be 2 times 34 degrees. So angle COB is 68 degrees. Activity for property 5. Draw a circle of any radius. And then draw a chord of any length. The chord divides the circle into 2 segments. Put a point on any part of the circumference in each of the segments of the circle. So we have a point here and a point here. And now we are going to join the ends of the chord to each of the points. So we have an angle here, which is, let's label it A, and another angle here, let's label it B. Now with our protractor, let's add angle A and B, and add angle A to B. If you got 180 degrees, then you are right. And that brings us to property 5, which says that the sum of the angles a chord or an arc subtends at the circumference of opposite segments of a circle is equal to 180 degrees. And let's apply property 5 to solve this example. The question says DB is a chord to the circle above. Angle DAB is 47 degrees. Find the size of angle DCB. So they want us to find this angle. And then the chord DB subtends an angle of 47 degrees in one segment, and the same chord is subtending an angle DCB in the opposite segment of the circle. So the sum of the two angles on the circumference should be equal to 180 degrees. So angle DCB plus 47 degrees should give us 180 degrees. So 47 crosses the equal to sign to subtract from 180 degrees. And finally, angle DCB is 133 degrees.